Welcome to Mission Challenge. These short projects will give you some real-life, hands-on experience using the skills you have learned. You will work in small groups to solve everyday problems. This week's Mission Challenge involves fractional parts. We are going to first look at different figures. Here we have a black rod that is one whole rod. Below we have divided the rod into 7 equal parts. Each part is 1/7 of the whole. If we have 2 parts, we have 2/7. And likewise, if we have 3 parts, we have 3/7. Here we have 2 parts. We have 2/7. The top number is called the numerator, and it tells us how many parts we have. We have 2 parts in this example. The number on the bottom is called the denominator, and it tells us what fractional part is being counted. Remember, our rod was divided into 7 equal parts. Here we have a circle, which is our whole part. We have divided it into 4 equal parts. Each part is equal to 1/4. Each of these figures has been divided into parts, but not all represent an object divided into fourths. Which of these figures are correctly partitioned into fourths? Take a close look. Figure A has 4 equal parts. Figure B has 4 parts, but they are not equal. Figure C has 4 equal parts. Figure D has 4 parts, but they are not equal. The same is true of figure E. Figure E has 4 parts that are not equal. Figure F has 4 equal parts, but figure G has 5 equal parts. Remember, when you divide a figure into fractional parts, all the parts must be equal. Figures A, C, and F all represent a figure divided into fourths. Here, each part is equal to 1/4. Count the parts and determine the fraction of parts. If you counted 7 parts, you are correct. But let's look again. Every time we have 4 parts, we have a whole. So we have 1 and 3/4. This week's mission challenge involves fractions. Think each problem through carefully, work in groups, and help each other out. Your mission is to solve fractional part problems using what you have learned about fractions. Here is your first mission challenge. If 8 counters are a whole set, how many are in 1/4 of a set? You might want to start by dividing the whole into 4 equal parts. If 15 counters are a whole set, how many counters make up 3/5? First, determine how many counters are in 1/5 of the whole. If 9 counters are a whole set, how many are in 5/3? A little hint, 5/3 is greater than 1 whole. If 4 counters are 1/2 of a set, how big is the set? If 12 counters are 3/4 of a set, how many counters are in the full set? First determine how many counters make up 1/4 of the whole. This question is worth 10 points. If 10 counters are 5 halves of a set, how many counters are in one set? First, figure out what a half is equal to. This question is worth 20 points. Be sure to think it through carefully. Be sure to report your answers under Mission Challenge number 4, Fractional Parts. You may work together in a small group to find the answers, but everyone in your group must individually report the answers to receive credit. Good luck on your mission!